Hello, so today we are doing this problem called Decode ways, and the problem says we get a message containing letters from A to Z, and it's these letters are being encoded to numbers using this following mapping. So A maps to 1, B maps to 2, C maps to 3, until Z, which maps to 26. So they are increasing here with the letters. So for example, with the number 12, it can either be decoded as AB, such that 1 is decoded for A and 2 is decoded for B, or with L using 12 mapping to AB. And this number 226, it could be decoded as BZ with 2 and 26, VF with 22 and 6, and BBF with 2 and 6. So this problem here falls into counting, right? Where we want to count all ways to do something, and this is often solved, can be solved with DP. So it's a good idea to whenever we see a problem like this, to think whether we can solve it with DP. But first, before jumping right away into DP, let's solve it with a simple brute force using recursion, and then from there we can do something like recursion with memorization, and from there we can go to DP. It's always a good idea to see these steps to really understand, I think, a dynamic programming solution. So the first thing we need to know is, okay, so here we know that we have A. We know that there are only two possibilities to count. So considering the number by itself, like only one number, like say 1, or considering two numbers, like, right? So if we have 1, 2, this one can be 1, can be counted with 1 and counted as 12, right? So looking at this, we know that when we are at a position I, we can check that. We can check S of I, but we also need to check S of I until I plus 2, right? Because so that we can get the Si and Si plus 1, so that we can consider the case where we are decoding the two letters or the two numbers as one letter, right? So that's the first insight. So the first thing we need to know is we want to do a recursive solution, right? So base case, what is our base case? So our base case is just when I is the length of the string, right? So let's say the length of the string is 0 or the length of the string is 1, and and I is at that position. It basically means we are done, and we can count only once. We can't do any more than just one, counting that number and decoding it. So for I equal to n, then we need to return 1. Now, what is the recurrence here? So the recurrence is that we have two things. We have the case where we have for decoding one number, and then we have for decoding two numbers, right? As one letter, of course. So for this case, the number of ways we need to add basically the next whatever. So it's we need to go to the rest of the string, right? So let's say we have 1, and then we have some other elements here, some other numbers, right? So we know that to decode the entire string would be just how many times we're able to decode this one, right? And this one would already be decoded using one of the letters, and so it's just let's call our function like helper, or let's call it number of decodings for so ways at I would be at I plus 1, right? But only under one condition. What if this wasn't a 1 or a 2 or 3? What if it was 0? In that case, we can't decode this one, right? Because we have no mapping for 0. Or what if it was -1? We have no mapping for -1. And so only if the number at Si is bigger or equal to 0, is bigger than 0, right? Only in that case we can go and count the next, and that would be the number of ways to decode. Otherwise it's 0, because if it's -1 or 0 or -2, we can decode, so that's 0, right? Now what about the case where two numbers, right? So in that case what we need to do is we need to say the ways at I would be, so let's say we are decoding two numbers, so that means we have something like 1, 2, and then we have the rest of the string. So we need to count decoding this if it's a valid number, because it may be like 84, right? We can't decode 84 because our mapping here stops at 26, right? So we can't decode 24, we can decode 84, and so that would count as the 0 ways to decode, right? And so for this 84 we need to decode only each one by one, and that's already handled by this case. But for 12 we need to check if this number is in the range. If it is, then we need to just count how the number of ways to decode the rest, which is I plus 2, right? And so this is number of decodings for I plus 2 if S of I until I plus 2, which is the string, is in the range 10 to 27, because that's what we are allowed. We can go to 10, which is in here in this range, and then 26 actually, closed interval. If we are taking a closed interval, it's until 26. Otherwise, then it's not possible to decode it. For example, the case of 84 here. And so in that case, we just it's 0, or we don't add anything, right? So pretty much that's all there is. So we have the base case, we have the recurrence. So let's just do this. I'm just going to define a helper function that does the recursion for me, so that I can initialize it with the. So the method here we need to return call to helper with this index I, right? Because that's what I'm interested in. So I, and we'll start out from 0, and then we'll keep going from the start at 0, and then we have that, so we'll decode the rest, and then we add that, and then we decode the rest. So that's what we will be doing here, starting from 0. But when we reach the end, that's our base case, we need to return just 1. There is no more, there is one way to decode, right? And then after that we need to handle the case ways. So the ways would be equal to what we said here, except the function is called helper, and this we need to say convert it to an int to be able to compare, and that's pretty much it. And the other case is this one, and that one would be ways plus same thing, a helper. So we can actually just do this, right? Or let's just keep it in a separate line. And so the next after I plus 2, and then this one we need to convert to an int so that we can check if it's in the range, and this we need to replace with range. And since it's a closed interval, we need to put for Python 27 so that we can get until 26, right? And then at the end, this one should return ways, right? And that's pretty much all there is for the recursive function. So let's run this. It will probably fail with time limited exception because, yeah, so you can see here at 223 it fails with time limited exception because it repeats the problem a lot. Let me just print here to show you that it recalculates a lot of things. So for example, helper for I here, and let's see for this how many times the same gets called. So you can see here 2 gets called 2 times for I equal to 2. If we take a bigger number, let's say 3, 1, so you can see here 4 got repeated 3 times, although we already calculated it and we know the value, so there is no need to go again and recalculate it, but we do in this problem, right? And so when we have a recursive solution like this that repeats, that recalculates a problem multiple times, we can just add memoization, and that would would speed it up, right? So that if we calculated something before, we don't calculate it again. By the way, the recursive solution here, the time complexity is O to the power O of 2 to the power of n, because we have two recursive subcalls that we do the length of s times, and so it turns out to be that. Now, if we do memoization here, then we need to have a map that saves the values, right? And so with that map, we can just say, okay, memo, if we already calculated that solution, which means that we put I in memo, then we can just return that. Otherwise, here we need to save the result that we calculated so that we don't calculate it again, and then we can return it. And that's pretty much all that's needed to memorize the solution. Just initialize the map, check if before calculating, check if the value is already calculated and is stored, and at the end, once we compute, save it so that we don't recalculate it next time, and that's pretty much it. Okay, let's submit. Okay, so that solution also passes now, and we don't get the time limited exception. So now that we did the recursive solution with memoization, so by the way, also for the time complexity for this one, it's not O of 2 to the power of n. Why is that? Because we go at most, we recalculate at most the length of n, because every time it was added, an I position was added to memo, it won't be recalculated again. So at most, this function will be called the number of memo times, the number of indices in the string times, and so that makes it linear. Okay, now let's do it using dynamic programming. So now we know that we can find the state using I+1 and I+2. But with dynamic programming, we'll probably need to go backwards. So we need to use I-1 and I-1 until I+1. And so let's just do the usual method for dynamic programming, which is we need a couple of things. We need to state our goal, and we need to state the state itself, which is the DP of something, and we need the base case, and then we need the recurrence. And so what is the goal? Is always, so here the goal is to find the number of ways to decode, right? So total number of ways to decode it. What is our state? So since from the goal function we can deduce that we can just calculate the number of ways to decode up until index I, and then from there we can decode I+1, decode I+2. So you can see with that state that really matches the goal statement here. We can go to we can also obtain the next state, right? So it would be, our state would be just dp of I, which is the total number of ways to decode the string to decode until index I, right? So what is the base case? So what is the for dp of 0, we can decode the first one. We know that we can decode it with just one way because it's one letter, right? So that's one. Now let's see our recurrence here. So our recurrence is dp of I. So how can we write it in terms of dpi minus 1 and hopefully dpi minus 2, right? So we want to write it in terms of function. Since those are the two things that we can handle, it's like decoding one letter and decoding two letters. And so in order to be able to know, since we can, our iteration would be from range of I and range of n, we need to, once we are at I, we already have dpi minus 1 and we already have dpi minus 2, and so we can use those. And so now we need to write it as a function of these two. So we know that this is the number of ways to decode until index I, right? And so we know that if if the element at I, the number at I is valid, which means that it's bigger than 0. So if it's 0, we can decode it, right? So if we have here 0, we can decode it. or if we have -1, we can decode it either. But if it's 1 or 2, we know that we can decode it by just getting the number of ways to decode the rest, which is or like by just using one number of ways that we were able to decode the rest here, right? And so to do that, so if Si is bigger than 0, then we need to say, okay, then we need to add dp of I minus 1. Otherwise, it's not bigger than 0, so it can't count, so we need to add 0, right? So if we have -1 here, well, there is no way to decode the entire string like this, and so, or the entire number, because this -1 messes up, we can't decode, so return 0. Now, what about for dpi minus 2? So for that one, we need to check that the two numbers, which are from I minus 1 to I plus 1, we need to check that, because basically this here just means that it's this here means that it's I, the number at position I minus 1, and the number at position I, right? So here we looked at the number at position just I. For the two letters, we need to look at the one before that, right? To see if using the new number we can decode the previous one in a different way, right? And so that would mean if this is in a range that is decodable, which means 26 from 10 to 26, that's the range of two numbers. So that's 10 to 26. Closed interval. So this means that if we have this, then we can decode just, so if we have a number like, let's say 21 here, so that means we can decode this one and then use whatever number ways we were able to decode dpi minus 2, because this is position I, this is position I minus 1, and this is position I minus 2. If this wasn't in the range, which is 84, then we shouldn't count this, because there is no way to decode 84. But there is a way to decode 8, and separately and for separately, but we are handling that with this case, right? And so only if it's something like 21 or 20 or 21, then we can decode it like this. So that means we need to add I minus 2 for whatever is to the left of that, and then else we can decode it, so it's 0, right? And that's pretty much it. And then at the end, when we reach the end here, we would have counted all the ways to decode everything, and including this one, and then we would just return dp of the last position, which is dp of n minus 1. And that's pretty much it. And so now we have all we need, all our dp solution needs. And so let's just start with this one. So we need first, let's keep track of the length. The second step would be to start the table that we need. So here, a range of n, and we need to go through, as we said here, and we need to do what we said here. So let's just arrange this a little bit. So we need if, so we don't need this actually, we just need if Si is bigger than 0, then we need to add dpi minus 1. So in that case, our dp of I needs to add dpi minus 1, otherwise it adds 0, so we don't need to add anything. The other case is if if this was in the valid range, so we need to convert this into a range. And so in Python, again, it's 27 to be able to have 26. And then we need to add dpi minus 2, so that means our dp of I needs to add, and otherwise, if that else is false, we need to add 0, so we can just not add anything. That would pretty much be the same. So this here is the same as what I did here. And so after that, what do we need to do? We need to return the result, which we said it's the goal function here is the last one, because we kept accumulating until the last one. There is just one thing here, is I need to convert to an int so that it can be compared with 0. And here, what happens if I is equal to 0, let's say the first iteration? This won't work, right? Because I minus 1 is minus 1. So I need to test against that. Because at position 0, I don't need to check for 2 numbers. There is only 1 number. And so I can just check this. And that's pretty much it. There is just one case here for dpi minus 2, which is if I is equal to 1, so it will pass this here, it will pass, it may be like, let's say we have a number that starts out as 10 or as 11 and then has 2 after that. So this one is still in this range, but the problem is there is no dpi minus 2, right? And so in that case, we can decode just one time for the 2 numbers. And so if I is bigger than 1, then okay, we have a dpi minus 2, but otherwise we don't. And so we need to count, we need just to say 1, because that's the number of ways to decode it. There is no dpi minus 2 to look at, right? And so that's just, this is just handling the edge case basically. Yeah, I forgot to handle another case. So here, the same thing happens here. What if I is 0, right? Then I minus 1 is dp of minus 1. So that's also problematic. So the same case that we had here for 11, if we have just 1, then we need to just count it as 1. There is no dpi minus 1 to look at. So this is kind of handling the base cases. I should have like done them separately, but it's fine to do them here. So that would be dp of so it would be just 1, right, for this number, and then you could go and continue calculating the rest. So if this is if I is bigger than 0, else it's 1. If I is bigger than 0, like 1 for example, we have dp of 0. If I is equal to 2, we have dp of 1. But for I equal to 0, this would be minus 1, so invalid, right? So we need to handle that case here. Okay, so let's submit this. Okay, so this solution passes. In terms of time complexity for this solution, it's we do n steps here, and that's all. That's pretty much all. So it's O(n) time complexity. In terms of space complexity, we use this array, but that's pretty much it. We use this variable which is constant space, but this one is O(n), the dp array, and that's pretty much it. So it's O(n) in time complexity and space complexity. So another thing when doing dynamic programming and we find that a space complexity is O(n) or O(n) squared, we can always think about ways to improve it. Here the time complexity, it's hard to avoid it because we have to traverse the entire string to be able to know how can we decode it. But for the space complexity with dynamic programming, we may be able to do something. And so how can we think about this? So to do that, we just need to look at the variables, at the indexes of the dp array that are used here. So you can see every time for a dpi to compute dp of I, we just need I minus 1 and I minus 2. We don't need the rest. We don't need I minus 3, I minus 4, I minus 5, whatever else we have filled the array with. And so instead of keeping an array, we can just keep track of these variables, right? And so how can we do that? And so the way to do that is, okay, let's just delete this. And let's just say we need, so from this solution here, let me just put it maybe this way so that we can have it. So we need the previous number of ways with I minus 2, with I minus 1, and then we need the one before that. And so for the one before that, I'm just going to call it previous number of ways, like this, previous ways. For I minus 1, it's just going to be the current ways of the previous iteration, right? And then I need to keep track of the previous digit, the one at I minus 1, so that I can check this condition, right? For this one, I just need to check S of I, but I need to check S I minus 1, so I need to keep track of the previous digit, right? And that's pretty much all. So let's initialize these variables. So the previous number of ways by default before starting is just 0. The current number of ways is depends on if S is empty or not, right? So if S is empty, is not empty, which means it's like bigger than this. If it was not empty, it would be bigger than this. In that case, it's 1. But if it's empty, then it's 0, right? And the other thing is the previous digit. So the previous digit when we start out is just an empty string, right? And then we need to go through the digits. So let's just say current digit. I could go through it with I, but let's just go through it like this, character by character. So the first one, let me compute the first one and then compute the second one. So the first one, which is from 1 digit, let's call it, which is the first step that we had here. And the second one, let's call it from 2nd digit. And so what does the first one need? It needs the I minus 1, which I said that I'm going to keep track of I minus 1 just as the current number of ways of the previous iteration. So before updating the current number of ways, that would be our dpi minus 1. And our dpi minus 2, it would be kept in previous ways, right? And so that means that here I need to add just the current number of ways, right? But only if this is correct. Only if the digit is bigger than 0, as we stated. So we need to check that. If that's not the case, we need to add 0, right? So in that case, it's 0. We need to add nothing. So we did this step here. The other step is, what if for the 2nd digit here, so we need dpi minus 2, and so we need to add the previous number of ways, and then we need to check this, right? We need to check that the number we have is in the range. And so to do that, we can just say if the int of the si minus 1 plus si, which is exactly what this is doing. So this basically is equivalent to just si minus 1 plus si, right? And in my implementation below, si minus 1 is just the previous digit, and si is just the current digit. So I can just use these, right? And so the previous digit comes first. That's the si minus 1 here, and then the si, which is current digit. So this here is equivalent to this one here. So if that one is in the range of the correct range, then I want to use the previous ways, which is dpi minus 2. Otherwise, it's just 0, right? Otherwise it's otherwise it's just 0. We skip it. Otherwise we skip it, so it's just 0. So an advantage of this solution is that we don't need to check the indexes, which is pretty nice because these are already initialized to 0, and to the current ways is already initialized to 1 for this case, right? And so now once we have the 2 digits, we can just say, okay, our new current ways becomes, so we need to fill the values for the next iteration. So we need to fill all these values for the next iteration. So what does previous ways becomes? Previous ways becomes the current ways from the previous iteration, right? And then the current ways becomes the value from let's call it new ways. Let's calculate it first. So the new number of ways would be the number of ways from decoding just 1 digit and the number of ways from decoding 2 digits, which is equivalent to what we are doing here by adding to dp of I this and then adding to dp of I this, right? So the current ways becomes this new ways, and then the previous digit is just the current digit. The previous digit for the next iteration is just the current digit from this iteration, right? And so at the end we can just return the current ways, because that would be the last number of ways that we found, because here I put in new ways, I put it in current ways, right? And so that's pretty much it for using, and you can see here we are using just 2 variables, so it's constant space. We are not using the entire dp array. We are just using the ones that we need. So let's run this. So here it's not si, it's current digit. Pretty much. Okay. Okay, let's submit. Okay, so this solution passes, and this solution in terms of time and space complexity, it's for time complexity we are still going through the entire string, so that doesn't change. But in terms of space complexity, we're able to go from O of n to O of 1 because we don't need the entire table, we just need these 3 variables. Yeah, so that's pretty much it for this problem. Thanks for watching, see you next time, bye.